Hey everybody, it's Mr. Mott. What I'm going to do is talk about the pH scale. We'll talk about the scale, how do we know if something's acidic, basic, or neutral, and then also give you some information about some calculations involved with pH. All right. First thing to know is that your pH scale goes from 0 to 14. Okay. And in the middle, we've got 7. Okay. And if I can kind of estimate on my drawing, there's pH 7. And for pH 7, we typically talk about pH 7 as being neutral. All right. So that's the pH that water should be. It should be neutral at pH 7. It's not always like that, but turns out water's pretty complicated. All right. If we are between 0 and 7, we call that acidic. And then if it's between 7 and 14, we call it basic. All right. Sometimes an old school kind of term for basic would be alkaline. Sometimes you see that with alkaline batteries, kind of lets you know what's in your batteries, I guess. And so that's kind of the basics of it. We typically use pH as a reference, although there's something called pOH, which we'll talk about in a little bit. It's important to recognize that the pH scale is based on something on the logarithmic scale, log base 10. All right. So like if we were looking at our pH scale, and I'm going to draw in some ones for acidic, and so let's call this 6, 5, 4, 3, 2, and 1. Okay. If we're looking at the difference between certain pH values, every change in one pH is a 10 times difference. So like if we looked at for instance, between 3 and 4, there is a 10 times difference in the pH value. Between 3 and 2, there's a 10 times difference. And what that means is that the pH difference between 4 and 2, there's a 100 times difference. So between pH 4 and pH 2, it's 100 times difference. Okay, so what we do with those values, how we got that, is that we took 10 times 10 to equal the 100. Okay, so when we're talking about differences in pH, the difference between two pH values is quite a lot. And again, this is all because it's the pH scale is based on the log base 10 scale. All right, and that goes for any of them. A quick way to figure that out is that you subtract your two pH values. So in this case, 4 minus 2 would be 2, and that's how many zeros we have. We have 2 zeros. All right, kind of a quick way of doing that calculation. All right. Now, what pH stands for is the power of hydrogen. Okay, so pH stands for the power of hydrogen. And that's kind of why we see that capital H there. So the power of hydrogen. Now, what they're really referring to is the hydrogen ion, which symbol is H+. And what that is representing is how much of that H+, or the concentration of the H+, that we have in our water sample. So it turns out, if we're actually going to numerically calculate it, this is the formula. You take the negative log of the concentration of the hydrogen ion. So these brackets mean concentration. We'll learn probably later in the year that concentration is in something called molarity. All right. Now the way that it works is, let's say that we know that the concentration of a water sample, concentration of those hydrogen ions, is say 1 times 10 to the minus 6. All right. If we were to calculate the pH of this, we would take the negative log of that in our calculator of 1 times 10 to the minus 6. And what that's going to turn into, it's going to be a pH of 6. And so it turns out that if this number in front is a 1, we take this negative exponent and you make it a positive, and it turns into the pH. So as long as this number is 1 in front, then the calculation is super easy. All right? So if we do like another example of that, so if I had a concentration of the H plus, 1 times 10 to the minus 10, our pH is going to equal 10. All right. We can also work backwards. Okay. We can also work backwards and do this. So if I know that the pH is equal to 3, for instance, I can calculate that the concentration of my hydrogen ions here is 1 times 10 to the minus 3. So we can work backwards on that as well. So that's how you do some of your calculations with pH. If the number that was in front wasn't a 1, then we'd have to put in our calculator and that sort of thing. But typically in our first year chem class, we just deal with concentrations where that value in front in scientific notation is just a 1. All right. Kind of a quick note in a related way, we mentioned that we have our pH scale, and I'll draw that again. So you have a pH of, say, 0 to 14, okay, with 7 being kind of in the middle if I estimate here. So this is our pH scale, and the pH scale represents how, like the acidity, how acidic something is, okay? There's also something called the pOH scale, which represents how basic something is. And so the pOH scale is sort of opposite. Your first value on the left is 14, and then it goes to 0. And so, so for instance, and I'll draw the number 7 in the middle again, all right? And then as we sort of number these, kind of show you how it works. Well, in my pH scale, okay, in my pH scale, let's make that purple there. My pH scale, let's say this is 1, this is 2, this is 3. And then on my pOH scale, counting backwards, this would be 13, and then 12, and then 11. If we were to look at and compare pH and pOH, they always add up to 14. So 0 plus 14, 14, 1 plus 13, okay, 2 plus 12, 3 plus 11, they all add up to 14. So that's an important relationship to know, that the pH plus the pOH are always going to equal 14. So that's a good relationship to know. And between this relationship here, pH and pOH, and understanding, this relationship mathematically using the log scale and everything, you pretty much have all the information you need to know about calculations involving pH. Thanks for watching.